Hey everyone, thanks for joining. We had like amazing presentations already, so really excited to hopefully you guys are gonna enjoy this one. So as Jose said, it's about like checking your yoga pose. I think we've all suffered pretty much in the past year and a half, and a lot of us have decided to try to stay fit and staying at home, and working at home, especially doing yoga, was a huge increase during this time. And one of the issues, and I'll explain in my white part, is that you don't really get any feedback when you train. Apart if you join a Zoom class, but in general, if you're following videos, you don't really know if your form is good, or if you have a risk of injuring yourself, or you might just plateau in your improvements. So that was the idea behind it. Obviously, this is a very ambitious project. For this demo Tuesday, I've decided to stay a bit lower than that, but it will still be like interesting, hopefully. All right, cool. So framing the problem. First of all, I went through a lot of the existing literature in terms of pose, classification, and form, etc. There were kind of like two different categories. There were a few yoga poses classifications built around 10 classes, something like that, using CNNs around 70% accuracy, which is really pretty good, considering that sometimes poses can be pretty similar to each other. And then you have like angles with the cameras and different background and etc., which make the training of the model a bit more difficult. And in terms of form, I found a very interesting blog post from someone who used his own webcam to check his form for pull-ups, and he used a certain system called dynamic type wrapping that I'm going to talk about a little bit afterwards, and also open poses models to check for different key points and recognizing different body parts. Some of the challenges that I wanted to tackle. So first of all, increase the number of labels, increase the number of poses that we want to detect. I tried to improve the accuracy from about 70-ish, hopefully a bit higher than that, and predict on the video, so not on an image, and then hopefully check if your form is good or not. Cool, so steps to solve the problem. First of all, gathering a lot of data. I looked at a lot of yoga pictures. I'll go a little bit into detail how I did it. Then the second part was to classify the different poses, and then the last part was, as I mentioned, checking for the form. Data set creation. So this is an example on tripods, for example. The way I did it is I used a Google script to download automatically from Google Images. There was a really cool JavaScript, and you can download hundreds of pictures at the same time, which is really cool. But then I still had to go manually after each of them. And the reason why is some of them were not the correct pose, some of them had not enough angle. You can see on the third picture, so the bottom left, you can't really see the left leg, etc. Or some of them were odds, like the top right, or too many people, like at the bottom right. So even though I would download about 600 or 700 pictures per pose, after feature extraction, I had about 120 per class, which is not a lot, and that was also very manual, so hopefully that would be enough. And at first, I tried with 21 poses, but I had to bring it down to 17 because a bunch of them, it was really hard to extract the body parts features, and I'll go into that in a second. All right, so to classify the poses, some of the existing literatures, what they've been using is the central picture, which is the regular picture of a triangle pose in this case, and basically trying to train CNNs on that one. We heard about, in one of the classes, about this open pose model, which is from some of the students from Carnegie Mellon University, which is really impressive, and it's like real-time body parts classification and detection system, And basically you can see on the left side, it's the original pictures with the key points and the body parts pairs, like linked, and on the right side, it's with a black background. After a few tests, I realized that the one on the right had the best compromise in terms of speed and in terms of training the models. As you can see, one of the good things is that it removes a lot of the cluttering from the background, because that's already taken into account by the open pose library. So it makes faster and better training afterwards. Quick words about open pose. Obviously you can read more. I put the link at the end. The way it works is that at the beginning they're using VGG19-like architecture to extract features, and then they have two branches On the one on top, one of them will check for what is called confidence maps. So if you were to look for the left shoulder, for example, you would have, I don't know if you can see me a lot, very well, but you would have a kind of a heat map around my left shoulder in terms of like, that's the probability that the left shoulder is here. The second branch will be creating path affinity fields, which are kind of like vector fields that would link body parts with each other. So my left shoulder with my left elbow, for example. So it would like try to like predict approximately the direction, and in the end, at the very end, it basically matches all those two different branches and creates like the body map that you can see on the left side. Obviously, it's not perfect. Sometimes with different backgrounds, different angles, etc., it makes it more complicated. But overall, you can see it online. It's really impressive what it's been doing, and I think it's been out for like four years, something like that. Cool. So then the classifier that I used. So just to repeat, I had about 17 classes, on average 100 pictures in each. And what I did is I processed them through OpenPose, and I got this black background with the body parts. Then I trained a convolutional model, which is kind of like relatively basic, a bunch of convolutional layers and a few dense layers at the end. And it's about 2.7 million parameters in my case. And I got 80% accuracy, which is so higher than like what I found online before. So I was pretty happy with that. I used Google Colab for the training. I used some data augmentation and TensorFlow and Keras. And then the next step was, how do I predict on a video, right? So one of the things is that I will extract each frame from the video. I would predict on that one, and then I would use a rolling average. I'm going to talk a little bit about that on the images to kind of like try to reduce the flickering. One really, and this is how it works. So basically, one issue is that if you predict on each frame in the video, one of the dangers is that one frame could be triangle pose, and the next one, it's not really sure. You think maybe it's warrior 2 pose or something. So if you look at your video, it would flicker very, very quickly. But if, let's say, over 3 seconds, or let's say 90 frames, 80% of the time you predict that it's a triangle pose, and 20% something else, then by using rolling average, it will just show triangle pose. So it will be smoothing a little bit the predictions. So 4 steps. First of all, I extracted frames using OpenCV, which is a great library to handle all videos and frames for computer vision. It takes about 0.01 seconds, so really quick on my laptop. It's all done on my laptop, a MacBook Pro. Then I extract the features using OpenPose. That's the longest. I return the black background with key points. It takes about 0.7 seconds. Then I predict on that frame using the CNN I just trained. It takes about 0.2 seconds. And it returns a predicted label that's added to your DQ object. And then every certain number of frames, I will return the best prediction over the past, let's say 100 frames before. And then I get the prediction. This is a video example of me. So sorry, I don't know if Tristan is watching, but don't judge my yoga poses too hard. So you can see mountain pose, that was good. So chair pose. So it's obviously not perfect. You see it's gonna flicker. You can see detecting all the things in the background, which is kind of weird. Tree pose is correct. It's gonna fail at some points. I kept it failing. Plank, it's not realizing things side plank for some reason. Chaturanga is good. And then you would see up dog doesn't think bow pose, which is kind of weird. So it's obviously not perfect. This is correct, but it's kind of fun to see that. I took a lot of videos of me doing yoga. I don't know if my neighbors saw me, but that was probably weird. That's correct. Warrior 1 is going to be correct also. So overall, it's doing pretty well. Here, it's like kind of confused when I'm changing. This one is confused also. You get the butt pose at the end. So also, it's always prediction after 1 or 2 seconds because I'm smoothing over like a bunch of frames. And then I think it's a few seconds. I'm not gonna keep too much on that one. And that's one is correct. And then I think at the end I'm just doing anyways. You can I'll put the video on GitHub and everything if you want to play with it. Cool. So the last part, which I sadly didn't have a lot of time to work on, but one of the most interesting one is, once I've classified the pose, is how do you check what is good or what is bad form? And that's very difficult to know. And I already told you I struggled getting the data set because it was very manual. There was a couple of data sets online of yoga poses, but they were not extremely big, and they also contained like wrong poses or like artwork of poses, which was not really good when I was looking for the body parts. So, we had like 3 different ways that I found that you could look at it. The first one is dynamic type wrapping, which is the one I mentioned earlier. And that's an algorithm that is pretty good at measuring the similarity between 2 time sequences that don't really go at the same pace or something. So one really interesting blog post was this person who was filming himself doing pull-ups and saving the key points coordinates, and then he would do a bunch of good forms pull-ups, and then he would do a bunch of like bad forms pull-ups. And then you could see that the coordinates of the key points, there was a clear difference in the way they were moving over time between the good and the bad form. And using the algorithm, it could detect pretty well with the threshold what was a good pull-up and a bad pull-up. So that was interesting, especially if you're considering a yoga flow of like a certain sequences of poses that's been fixed. But the issue is that you kind of need the same angle every time and the same person, like the same kind of size. So that means you kind of have to train on yourself. But it was pretty good for yourself. It gave some interesting results. And I like the logic behind it. Integrated gradients, so Antonio mentioned that, we saw that in his class. So that would be also training a CNN and basically trying to see when it fails on what it tries to classify good, a binary classifier between good and bad form. And then when it's bad form, you're trying to see what feature, what part of the picture is actually not, it's kind of failing into bad form. And with that, you can try to see where you need to improve. What I used is the autoencoder. So I'm glad the team before me just introduced encoders because that was very useful. Basically, you compress the data. I'm not going to repeat too much into the latent space, and you try to reconstruct it. One of the good things about it is that you can basically train only on good form, which, if you go on Google Images and you look for like a certain pose, then most of the time you're going to have good pose, right? One of the issues, I think, is that it's kind of hard to understand where is the bad form coming from. Like, let's say your legs are not straight enough. Like, it's kind of hard with an encoder. It might be possible with a lot of data, but I didn't get to that point. So I trained only on one pose. I didn't have a lot of time, and that was the one that I had the most data on. And my architecture, my autoencoder was a convolutional one, 5 layers, plus a dense layer, 32-dimensional latent space, and then the decoder was basically the symmetrical of the encoder on the other side. Like, that's a very simple example of a tree pose. So on the left side, you can see that basically the key point, the body parts from the person, and on the right, it's the reconstructed image via the autoencoder. It's not great, but at least you can see the similar shape. So I thought that maybe I could find a threshold for which it could work. And I actually managed to get that about 2 hours ago, so pretty excited. So that's bad form. This is getting into good form. So that's like normal, and then I'm gonna put my foot down, it's bad form again. And like that's what I'm trying to do, like on my ankle, it's bad form, and then I go back, it's good form again. And then like I just move my arms and it goes back to bad form. So I was actually surprised in a good way that it worked that well. I was not expecting that, to be honest, so pretty happy. Yeah, so challenges in the future. Challenges, creating the data set took a long time. I think everyone who had to create their own data sets know that it's a lot of manual work. Picking a good open pose implementation, there was a lot of them. I tried. Some of them were faster, some of them were slower, some of them get better results, some of them worse. It was a lot of like try and error. It took me a long time. Tuning the model, I ran maybe 3 or 4 different Google Colab pages in parallel and trained overnight and everything. So it took a while, but I got 80%, which I'm pretty happy with. And the autoencoder datasets were pretty small. So that's something that I would work on. In the future, basically increase the size of the data set. If I were to carry on working on this, try different implementation, maybe MediaPipe, which is a really cool implementation for mobile phones, so potentially creating an app. And then train you into autoencoders, because you need one architect, or you need maybe the same architecture, but you need one different model for each pose, which is what Niklas mentioned, Niklas, Sarah, and Riju mentioned in their presentation just before. And also it would be great to detect which part of the body has like bad form. I built a web app, it's pretty cool. So like right now I could also train it, I could use on my webcam. So I have a script that turns on my webcam and I can do a bunch of poses and then check the results on that. Also one thing is like using the key points coordinates in a better way. I didn't really do it, but every time not only do you have the image of the key points of the body parts and the body pairs, but you also have the coordinates. So I was thinking maybe I could try to train on that, maybe using boosted trees or random forest and see if it gives something. And then obviously put everything in GitHub. And also be able to do what the guy is doing on the right side. That's also what I want to get to in like a month. So thanks to Tristan, Antonio, Sarah, asked them a bunch of questions. Thanks to Jose, Aaron, everyone at DSR, all my classmates. I had a really good time. I learned a lot. I had a lot of fun, despite difficult times. So I'm really happy we went through that. And a few resources that I went through. Like there's a lot of like really interesting stuff online. So I encourage everyone to go and read about that. Thank you.